Elon Musk has completed the AI5 chip, as powerful as Nvidia's $30,000 GPU, consuming only 250 watts of power, compact enough to fit directly inside a robot's chest. Tesla has decided not to put it in cars first. Instead, it's going straight into Optimus Gen 3. With AI5 inside, Optimus Gen 3 self-learns from 8.2 billion miles of real-world data, handling every situation on its own. No Wi-Fi needed, no cloud needed. Tesla is setting up a production line of 1 million robots per year. Could this be the biggest upgrade in the history of robotics? Let's dive in. To understand why this matters, we need to know what tape-out means. In the semiconductor industry, tape-out is the moment a completed chip design is sent to the manufacturing facility, the point of no return. Tesla's AI5 chip has been completed. It's real and it's about to go into mass production. Samsung in Texas and TSMC in Arizona will handle production. Tesla is also building its own chip factory, Terafab in Austin, with a $20 billion budget in 2026 alone. But what surprised everyone isn't that the chip was made, it's where it's going first. Not into cars, not into the cybercab robo-taxi. AI5 is being prioritized for Optimus Gen 3, the humanoid robot Elon Musk once called Tesla's most valuable product. And with that decision comes a bold target: 1 million Optimus robots produced every year starting in 2027. There's a harsh truth about traditional intelligent robots that few openly admit: they're not actually smart on their own. Most AI robots today depend on the cloud. The robot collects sensor data, sends it to a server, the server processes it and sends back commands. That works fine until the Wi-Fi drops or the server overloads. In a factory, that means an assembly line halting, tens of thousands of dollars lost every hour. The second problem is power. The most powerful AI chips like Nvidia's H100 consume over 500 watts and cost $30,000 each. A humanoid robot's battery holds only 2-3 kilowatt-hours. At 500 watts, the robot drains in under 6 hours, and that's before accounting for motors and sensors. That's why no one has built a truly autonomous humanoid robot at industrial scale until now. Tesla just found the solution. AI5 is 8 times more powerful than AI4, 9 times greater in memory and 5 times faster in bandwidth. One AI5 chip matches Nvidia's H100 in inference performance, but uses only 250 watts, half the power. At 250 watts, Optimus Gen 3 can operate through an entire factory workday. And since all processing happens inside the robot's body, it needs no internet connection. Every decision is made on the spot, instantly. Tesla achieved this by doing what Apple did with Apple Silicon, removing every component that Tesla's neural networks don't need. No conventional GPUs, no standalone image processors, no unnecessary modules. The entire chip area is focused on one thing: running Tesla's neural networks as fast as possible. The result is a chip that costs, in Musk's words, peanuts, yet performs like $30,000 worth of hardware. Optimus doesn't learn from a robot lab. Before it set foot in any factory, it had already inherited the visual knowledge base from 4 million Tesla vehicles, 8.2 billion miles of real-world driving data under every condition: sun, rain, darkness, highways, narrow alleys, unexpected obstacles. This is an advantage no competitor can buy. Boston Dynamics, Figure AI, Unitree, all building their datasets from scratch. Tesla starts with 8.2 billion miles. For hands, Tesla sent engineers to the Fremont factory to film workers doing real jobs: how a human grips a small component, how the body adjusts balance when carrying weight, how eyes scan before entering a tight space. These natural movements were fed into the training system. Optimus learns by watching humans, like a child learning to walk without being told how. Tesla is also developing the ability for Optimus to learn tasks from internet videos, show the robot an assembly tutorial, and it understands and executes the procedure. This is still in development, but it reveals Tesla's long-term ambition. The most impressive part is the Neural World Simulator, confirmed by Tesla's VP of AI Ashok Elaswamy in November 2025. Unlike traditional 3D simulations using pre-programmed physics, this system is trained on billions of hours of real footage and generates completely realistic new scenarios: shifting lighting, moving objects, unexpected situations. Optimus trains inside this world tens of thousands of times, failing, learning, improving at speeds hundreds of times faster than reality. This is Tesla's true greatest advantage. Every Optimus robot in a factory collects data continuously. That data goes to a central system, lessons are extracted, and updates are pushed to all robots via OTA, exactly like Tesla's vehicle software updates. One robot solves a problem. Hours later, the entire fleet knows the solution. As the fleet grows from hundreds to thousands to 1 million, the learning speed increases exponentially. More robots equals more data equals smarter AI equals more capable robots equals more sales. That loop compounds and the gap versus competitors keeps widening. It wouldn't be fair to only cover the positives. First, the gap between announcements and reality is wide. At the Q4 2025 earnings call, Musk himself acknowledged that Optimus robots in Tesla's factories are currently in R&D mode, primarily collecting data, not yet generating economically valuable output. 1 million robots by 2027 means 1 million manufactured. Their actual work performance is a different story. Second, AI5 isn't in Optimus yet. The chip completed design in April 2026. First engineering samples are expected late 2026. Large-scale integration into robots is a 2027-plus story. Third, the competition isn't standing still. Boston Dynamics has 30-plus years of experience. Figure AI has Microsoft and OpenAI backing. Agility Robotics has an Amazon contract. Chinese companies like Unitree are making humanoid robots for a few $1,000s, far below Tesla's $20,000 target. They lack Tesla's data and flywheel, but they have speed and cost, two things the mass market cares about deeply. Tesla's true moat is the fleet flywheel, not the chip, not the robot design. Chips can be copied, designs improved. But 8.2 billion miles of real-world data combined with millions of robots learning in parallel 24/7 cannot be built overnight. That's exactly why Tesla prioritized AI5 for Optimus over cars. AI4 is good enough for cars. They need AI5 to activate the autonomous learning loop as early as possible. Every month of delay is a month the flywheel isn't running at full speed. When it spins fast enough, it will be very hard to stop. 1 million robots, self-learning AI, a chip more powerful than a $30,000 GPU. This is happening right now, not in a science fiction film.